Today we're here to talk about a very important pest that affects colonies around the world, and that would be the pest known as Varroa destructor. Varroa destructor is one of many species of Varroa, which are a type of parasitic mite that affect bee colonies. Varroa destructor, however, has become a notable entry in that log of parasites, as it has continued to evolve past the point of immediate control through the miticides that are available worldwide. Pesticides are known to usually be used in a plethora of insect and, of course, other types of control. This, however, does not mean they are universal and also offer the same amount of control. In earlier times, when Varroa was first seen as a critical parasite of our fellow bees around the world, the pesticides and miticides that we used were pretty good at controlling them. However, as seen here, there has been a large decline over the years. Through these graphs, it can be seen that at first we had a pretty marginal amount of decline due to the use of miticides, and over time it has of course gotten worse, meaning that Varroa has started to adapt and overcome the miticides that we are using to actually control them. Before we dive too deep into this, we're going to talk a little bit more about the actual lifestyle of Varroa. Varroa themselves are very dangerous parasites that infest bee colonies through the use of multiple stages of the bee's life. They start off here, where they burrow into the bee's comb with their eggs. From the next stage, they go about infesting the larva and laying eggs in that comb and draining the bee of its fat body. They were once thought to drain hemolymph, but it has been found out that they specifically only target the fat bodies of bees and continue to do so throughout the lifespan of that bee. It has also been found out that they do not target bees in their adult stage immediately, but of course start with them in the comb at their birth. This almost symbiotic relationship that they have, obviously specifically only parasitic, will go on for the rest of that bee's life until the bee dies or the Varroa at its fully adult stage leaves the bee that it is currently traveling with and goes on to infest another comb or infest another egg cell. At that point, the cycle begins again and the colony suffers. The problem, or the biggest problem, however, with Varroa, outside of the fact that it can kill multiple bees, if not a colony itself, is that Varroa spread very harmful diseases. These harmful diseases can range through a plethora of these shown here, leading to multiple health problems, if not the death of the bee itself, which could also cause colony collapse. And the biggest question that we have to ask ourselves is, are there any other changes or any other way that we can control Varroa? It has been found out that through a bit of gene splicing or just overall breeding in general, there are ways to gain or garner resistance in bees to Varroa. However, this could also be a dangerous method, as it could lead to a multiple die-offs or genetic bottleneck before the bees themselves gain a resistance. You are weighing your options of, will my bees adapt fast enough, or would it be safe enough to implement the integrated pest management system and just reach straight for chemical control? The other problem with miticides is that they will definitely seep into the actual comb of the beehive, which could lead to further problems down the line with the bee's health and also any products that you get from your hives. In the end, Varroa is a very important pest to keep an eye on, and of course we will be keeping an eye on it in the near future, as it goes hand in hand with beekeeping and bee management as a whole. Further into this video, I will go over a few more graphs and try to think or get my thoughts on the idea of how further implementation of pesticides and overall control methods could work to handle this pest.